Hi folks, welcome back to 4.7 practice. So in this video we're going to take a look at question number 2 in the practice packet. So question number 2 reads, owners of a car rental company have determined that if they charge customers P dollars per day to rent a car, where P is between 50 and 200, the number of cars N they rent per day can be modeled by the linear function N of P equals 1,000 minus 5P. How much should they charge to maximize their revenue? All right. So this one, I would say, is a little unlike number 1 in the sense that drawing a diagram might not be super helpful here. However, we can start in the same place, which is to think about what equation we need to write to find the derivative of. And so that is right here. It says maximize their revenue. So the equation we want to start off with here is a revenue equation. All right. Now this is useful for those of you who are maybe going into business or just want to know a little bit more about finance. But revenue is the same as your income. So like how much money you're going to make, okay? Now it doesn't take into account the cost of like their overhead. It's just sort of like how much money is coming in the door. And so in this case, our revenue of the cars, okay, so we'll call it R of P, is going to be the cost per car, and we're going to multiply that by the number of cars that they rented. So number of cars rented. So if it costs $10 per car and they rent 20 cars, they'll make $200, okay? Now let's figure out what variables from our equation we can use in here. So R of P is going to be, well, they say that they charge P dollars per day. So the cost per car is going to be P, okay? And the number of cars they rented, they give you an equation for that. It is going to be 1,000 minus 5P. Now, the nice thing about this question is, unlike number 1, it already comes in a single variable. All right, so that's important to recognize that this is already with a single variable. So we don't have to find another equation to substitute in, okay? What we can do is go ahead and just simplify this equation. So R of P equals 1,000P minus 5P squared. And this is what I'm going to want to take the derivative of. Okay, so let's take that derivative. dr dp equals, the derivative of 1,000p is 1,000 minus the derivative of 5p squared is 10p. Now, we want to think about maximizing their revenue. We want them to make as much money as possible. So at the maximum point, we know that the slope is 0. So we can say that dr dp equals 0. So I'm going to add 10p to both sides, and I'm going to divide by 10. And I will get a cost per car of $100. So if they rent out cars for $100, then they're going to make the most amount of money. And if they charge more than that, fewer people will rent, so they'll make less money. Okay. So they ask for how much should they charge to maximize their revenue, and we answered the question. Let's take it one step further. And what if I say, what is the maximum revenue? So how much do they make if they charge $100 per day for a car? Well, we can put this back into our R of P equation from above, which was 1000P minus 5P squared. And everywhere I see the letter P, I'm going to go ahead and put in 100. So R of 100 is going to equal 1000 times 100 minus 5 times 100 squared. And that will give you a maximum revenue of $50,000. Okay? So, let's go back and think about what this might mean graphically if we wanted to check our answers, maybe at this step right here after we came up with the equation. So at this step, you could plug that equation into Desmos and graph it. And what you would see is a graph that looks something like this. You would see an upside down parabola. And the maximum point, the coordinates would be P and then R of P. And the numbers you would get would be 100, comma, 50,000. And that's because at a cost of $100 per day, the car rental company will make $50,000, which is the most amount of money they can make given their modeling function. All right, so let me zoom back out so you can take a look at the whole screen. All right, and that's it for this question. So we're going to end the video here, and we'll do a separate video for practice question number 3. All right, see you there.